Okay, folks, example number 1 here. It says find the distance between the points. Write your answers, or write your answer in simplest form. Okay, so I've got -4, 2, and 5, -1. Now, guys, you're going to remember, I'm going to go back just to the stuff that I wrote here for the intro. You remember when I found the distance earlier, I didn't use this formula, okay? I didn't use the distance formula because I actually put it on the graph and I found the distance using the Pythagorean theorem, right? The bottom here, oh, I don't want to do that, okay? The base and the height of the triangle, okay? But you can see with the distance formula up here, distance equals the square root of the differences between the x's squared plus the differences between the y squared, all right? And that's just basically the Pythagorean theorem, and I'm going to show you an example 1 here, all right? Let's say that, remember, a squared plus b squared is equal to c squared, yeah? So if I want to know what c is, I have to take the square root of both sides, like this. So c is equal to the square root of a squared plus b squared. But remember, I don't know the base of that triangle between, if I have a point here and a point here, right? I've got a triangle that sort of looks like this. To find out what a is, I'm going to take the two x's and I'm going to subtract one from the other to find out what the difference is between them. So instead of a squared, it's x squared minus, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, that's just to find out how long these sides are. I subtract the differences between the x's and the y's, or I find the difference between the x's and the y's. And that's going to tell me what c equals, right? And here's c. Okay, so let's look at these 2 points. And I'm going to use the formula. The distance between them is this, right? The difference between the x's, so that's going to be, let's do -4 minus 5, and then 2 minus -1. All right, put my little parentheses in there. Oh. All right, put my parentheses in there so I don't get that mixed up. Okay, so that means the distance equals this. So the distance is equal to, let's see, -4 minus 5 is -9 squared plus 3 squared, right? Then I'm going to square the -9. I'm going to get 81 plus 9. All right, so that's going to equal the square root of 90. All right, now guys, you remember I've got to simplify the square root of 90. So let's do that. Here's 90. Break it down. 2 and 45, and 9 and 5, and 3 and 3. You guys remember how we did this from the last section? Okay, so then I've got root 2 times root 3 times root 3 times root 5. I've got a pair here, so that's going to give me 3 times root 2 times root 5. And I always multiply the things that I can. I can't multiply the 3 times anything because the other stuff is just radicals, but I can multiply these two, and I get 3 root 10. All right? So the distance between those 2 points is 3 times the square root of 10. Now, if I go back and look at the directions, I don't think they asked me. It said just simplest form, so reduce the radical. They didn't ask me for the decimal form. But just on an idea, it's probably about 6 or something like that, maybe. You know, 3 times the square root of 10, the square root of, no, I'm sorry, the square root is just going to be something like 9, it's going to be something like 10, 11, something like that. Okay? All right. Good job, guys. I think that we've got it. Remember that this distance formula will help us when we don't get to graph it. I didn't graph that thing. All right? I just plugged in, I found the difference between the x's, right? And I found the difference between the y's. That gave me the 2 sides of the triangle, right? And then I squared them, and then I added them together, and I took the square root of it to find out what c equaled. Okay? Good job, folks. See you at the next example.